dynamics of air friction. Uh, Remember, we did a lab on that where you calculated the terminal velocity of the paper plate. Then it went, and then you determined the terminal velocity. So that's the kind of stuff I'll cover Wednesday. So dynamics of circular motion, you're applying still Newton's laws, but you're particularly focused on forces that cause the object to go in a circle. Okay? Whereas the forces in chapter 5 are objects that are going up and down the incline or in the horizontal direction. So this is called centripetal. Sum of the forces centripetal is equal to mv squared over r, because the acceleration centripetal is v squared over r, right? So the what kind of motion is, for example, a car going in a circle? In that case, the friction force between the car's tires and the road is what enables the car to go in a circle, right? So car going in circle. So that's one example of circular motion. Car is going in circle. B, the other one is strings tied to block or tied to object going in circle. The other cases like roller coaster rides, roller coaster, the Ferris wheel. And then the other kind would be, you do this more in physics too. It's going to be the planets going around stars. Those are all circular motions. Okay. So in the case of a car, we'll start with a car on a flat road. So a car weighing 3,200 pounds is going around the curve of radius 80 feet where the coefficient of static friction is 0.6. What is the maximum safe driving speed of the car? Okay. I'm hooked to these valves.
At Costco, they sell a really good one cheap.
Yeah.
Like $17 for like 5 of them.
Yeah.
Yeah, that's where I get mine.
This one of them is like $10.
I know. That's why I go to Costco. It's the Kirkland brand, but it's the same as like Flonian.
But you can get a little bit addicted to please. I'll hurry.
I figure I'm gonna breathe no matter what. I might as well breathe
I have to
well.
breathe though.
Yeah.
You know. Okay, so you have the radius of 80. So from the top view, it looks something like this, right? So you don't necessarily have to be going around the complete circle for you to use this equation. It could be a portion of a circle. Then the road can get level. Then you could turn this way. Right? So as long as you're making portion of a circle, you're making circular motion, right? And then every curvature, right? Every curved space has a radius of motion. If I remember correctly, I'm not 100% sure, in calculus 3, don't you learn the equation of finding out the curvature? Based on the curvature of an equation, you figure out a way to calculate the radius of that curvature?
1 over curvature.
1 over curvature?
Yeah, that's for a circle.
Maybe I should incorporate a Calc 3 problem there. Right. Because based on the radius of curvature of that, there's a certain speed, maximum speed you can drive it. Okay, I gotta look at the calculus book, remind myself of that equation. Wednesday. Okay, so the friction force is gonna be pushing you in, right? Because the idea is that your car would prefer to go in a straight line, right? And it's the friction that's preventing it from going in a straight line. And so the tires are moving this way, but the friction is perpendicular to the direction that the tires are moving, right? This isn't the other friction. There might be friction this way too, opposing the tire's motion, you see? There's two frictions. One is in the direction that, opposite the direction that the tires are moving, right?
I feel like the reason why there's a friction going to the circle is because there is a force, like tendency, like going.
But there's no force. There's just
there's
a
no
tendency.
Force. There's a tendency. That's
Yeah,
why
there's a
it's going.
tendency of the car to look like it's moving outwards.
Yeah.
Do you see? But it looks like it's moving outwards. Centrifugal, right? Remember the omega crossing the V, all that centrifugal stuff? So yeah, there's a tendency for the car to slide this way, but the friction is preventing it from sliding that way.
Right.
So if you look at the tires from the back, imagine this is the car, there's a friction force this way on the tires, but there's also a friction this way too, tangential to the direction. But we're interested in this friction, mu, and the maximum that it could equal is the mu Sn, right? And so since you're on a flat road, if you're on a flat road, the N will just equal mg, right? So the N equals mg, and what else happens? Then you have mu Sn equals what? mv squared over r. The friction force is what's allowing you to make the circle. Now, how can I assume in this case, and don't just Jasper answer it, wait for someone else. How could I assume that the friction is equal to its max? Remember I told you friction is not necessarily always equal to mu Sn. Someone from the back row, the middle row, everyone get involved. How can I assume the static friction force equals to its max?
It's not moving that direction.
Okay, he's saying because we're not moving in the outward direction. Yeah, that's true, but still.
I just threw that.
You're getting close, getting warmer. I know Jasper's like, he's just killing himself to not answer. He wants to. Brian? Why is the friction force equal to its max? Look at what the question is asking.
It's centripetal.
Look at how it's worded. Yes. Eduardo, right? Okay.
It has to be going in so not be.
Because the wording is right, yeah. Because we want to find the maximum safe driving speed. So when you're going at your max, you're barely on the verge of starting to slide outward.
Yes, you don't want your centripetal force greater than the maximum of your the friction.
So if you're driving slower
Right.
than the maximum,
That's it.
is the friction going to equal to its max? Right, imagine I'm just walking in a circle.
No.
There's a friction between me and my shoes and the floor too, right? But if I'm going slow, the friction force is not the max, equal to its max. But if I really run, right, and I turn, right, what's the maximum that I can run and turn, right? Then that's equal to the maximum friction that it can be supplied. Then that's equal to mu Sn, right? So imagine, like in basketball, you do really quick turns, right? Quick turns, you're relying on really good shoes and good traction. But if you're just playing normal, regular pickup game, you're not doing very quick turns, you can have worn out shoes because you're not pushing your shoes to the limit of the friction force.
Or if you're like in your socks, you just slide off in the distance.
Yeah, exactly.
Kinda-
Like a couple of weeks ago, who was the guy who tore his shoe in the college basketball? Zion, right? His foot literally went through the shoe because he was making a turn, and his whole shoe ripped, and his foot went through the shoe because he was trying to make a turn very, very fast. You know, so yeah. So that's how we know that we put, in this case, Fs is mu Sn, because we are trying to find the maximum velocity to make the turn. You see? So now we're gonna have, what's the n gonna equal? N is gonna equal mg. M cancels, so V max equals mu s rg. Okay. So then V max equals square root of 0.6 times r is going to be what? 80 feet. Notice that this is given in feet. I'm going to keep it in feet, and then the g I'll use 32 instead of 9.8. So obviously, if you're making a turn, you want the road to have a good friction, you know, the mu s as large as possible. So what is that equal to? .2 feet per second, right? If I want to change that to miles per hour, I do 5280 feet is 1 mile, and then 30,600 seconds is 1 hour. So they should post that on the road, 26.7 miles per hour. But would you post that, or would you post the smaller than that? Because that one is relying on the fact that the friction force is 0.6, the coefficient of friction. What's the typical coefficient of friction of tires? Right? Let's say there's a range, depending on what the tire kind is, the wear and tear, and the rain, whether it's raining or not. What would you do? Well, if I was the person, the engineer designing the road, I would work off the lower end of that range, not the higher end. Because, you know, what if someone has bad tires? I don't want to put the maximum for good tire.
Oh, what if it's raining?
Yeah, what if it's raining?
It's terrible.
So the cool thing is that it doesn't matter what the mass is.
Well, notice that it didn't matter on the weight. What happened? How did the weight drop out? Well, the friction force, the maximum possible friction depends on your weight, and then your mass depends on it. In other words, the heavier the object is, the more inertia it has, which means the more it wants to go in a straight line, right? But the heavier it is, there's also more friction,
Oh.
because it's settling into the ground more. Right? So if you're heavy, you have more tendency to go a straight line, but it's counterbalanced by the fact that you are into the ground more because of your weight, and there's more possible friction to help you. Therefore, it doesn't matter the weight of the truck or the car. A truck and a car can go at the same speed.
Wow. I would not have.
But the problem with the truck, of course, is
They're long.
there are also tipping problems if you go too fast.
Okay.
Is it the
Doesn't matter.
higher, the less safe?
Yeah, the higher the car and the narrower the car.
No matter how long the vehicle is, too, because one at the back.
Yeah, there's also the
Yeah.
back issues. Yeah,
Yeah.
those semi trucks. Yeah,
Yeah.
you wouldn't want to drive those. Coefficient of static friction for tires.
Because in the front of the truck would have centripetal force, but not the back.
Jones and Childers report coefficients of friction of about 0.7 for dry roads and 0.4 for wet roads. On dry surface, you might get as high as 0.9 as a coefficient of friction. Right?
Huh. That's why you can drive faster to Vegas, because it's always
So
dry.
0.7 for dry, 0.4 for wet. But it could go as high as 0.9. But driving them on wet roads would be dangerous since the wet road coefficient might be as low as 0.1.
But like supercars have the really high ones, right? Like,
Yeah?
yeah, like they have like different threading on the tires, like they're like the big wheels.
Coefficient of friction 0.7 for dry road.
There's specific tire.
Does that mean the drier the road, the safer it is to drive on?
Of course, the drier the road, you can drive faster. Yeah.
Like,
Huh? On a hot day,
I mean,
probably there's some effect on of the temperature on the coefficient of friction too, I think. Yeah, the rubber too, yeah.
You can drive to Vegas at 75, right? And it's like the highest speed limit I've seen around here.
I'm trying to see if there's
it's like
another.
some of my friends like to drive.
Or what else to do, because it's always dry, always hot. Because it's a straight line.
Yeah. The one that goes to Angeles Highway, the one that goes to like
Well, this is pretty nice. It's like a table.
goes to La Cañada.
The internet is just so amazing. We just look.
Yeah.
There's so many good stuff now. Look at this. It's like a thing you can put dry asphalt, concrete, wet asphalt, friction coefficient, rolling resistance coefficient. So besides static friction, there's mu sub R, which is the rolling friction. Because something is rolling, it's called mu sub R.
It's different.
Does it change
Right.
does it change the rotation of the tires?
It doesn't change the rotation, but it causes the tires to eventually burn out, and it's what why you want to usually have the tires on the right pressure.
I think
Because
the
if it's
former-
low pressure, you're gonna spend more gas, right?
Yeah, right.
If the tire does not have enough pressure in there, they say you're gonna waste gas. Why? Because of the rolling friction increases. When it's a flat tire, the rolling friction coefficient increases.
Or if you change the size of your tires.
Huh?
Like some people get bigger tires and it changes their
Yeah,
whole gas
so let's
mileage.
see if we test out something here, what's gonna happen. If we do high performance stock car
I swear everywhere I go.
with, did we change that? With? No?
Yeah.
I think you can.
Pressure coefficient based on tread wear, gravel.
Or maybe you have to click that bottom one.
It's not allowing me to do it.
So that top one on a friction coefficient, try it based on tread wear, see if it lets you. No?
Oh, it even has the tread wear.
Or maybe,
Pressure coefficient for street tires on dry asphalt.
weird. Maybe there's a glitch. Check different. It's weird.
What's a typical tire? Stock
Stock,
car.
stock car, yeah.
Pressure coefficient 0.96.
I don't know why you can't fix the tire.
That's short dry. Right?
Yeah.
And then rolling resistance 0.02.
It's like if you, it feels like a roll of traffic, right?
Weird, isn't it? Yeah, I wonder if they did it.
You shouldn't go next
They
to
did like
the
in
curb.
cascading style sheets or
It's
something.
not letting me do it, huh?
Didn't- Somebody didn't program that
So
right.
I did have to pull up to the curb.
Sometimes I get some thoughts. I was driving my car and the kid opened his door and then it hit my car and he got mad. Later,
Oh, you see that? Rolling friction depends on
karma for me. I was
car tires rated conditions, bias and radial.
He opened his door and then it hit my car and he got mad. Yeah.
So how does the size?
Oh,
of
look at this.
tire-
Coefficient of rolling friction increases with increasing speed. That's why you don't want to drive at high speed, right?
Yeah.
All it has to do
Because
is-
you also waste gas. There's an optimum speed. I think 65 or 55 to 65 is the right speed, right? For
Yeah.
gas, to save gasoline. Because you're increasing rolling friction when you're driving faster.
So how does the size of the tire affect this?
There's probably some graph. Oh, there's an inflation pressure.
I don't know. You think some pressure.
Like,
The
Okay.
inflation pressure of the thing.
I'm just wondering, like,
Oh, depends on what you're riding on. Whether you're driving on concrete, medium hard soil, or sand. So most of us are driving on concrete, right?
yeah.
So it tells us if you inflate it more, what's the typical pressure of tire? 30, 40?
Yeah, 30, 40 PSI.
Yeah, but if you're going on 20, which sometimes I am, because I'm too lazy to freaking fill up the air, see my rolling friction is higher. See this graph?
Yeah.
But it's interesting on sand, you want it to have higher pressure.
Yeah.
Because you don't
No,
want-
sorry. On sand,
It's like the spring. And then like the
See.
property we have, like the metal they use for that actually reverts.
no, on sand you want it the opposite. You want less pressure on sand.
That makes-
Because you want mu sub r to be less.
So it'll kind
Because it's telling you the more pressure you have, the more mu r you have. So in the sand you want to kind of settle down more,
of, yeah.
right? Does that make sense? Or that was kind of odd.
What's it called?
Kind of like the tanks where they don't have tires, they have.
What is it?
Oh, what? No, sorry.
But medium hard soil, it doesn't really matter. But concrete, definitely you want it 30 to 40 psi. Right, Alan? Okay. What's the next graph? We can keep going and going. This is an interesting topic.
Yeah.
So if you have this higher pressure, wouldn't you also burst your tires?
Huh?
If you have higher pressure and your tires, would not also burst the tire?
Well, yeah, of course, I'm not saying exceed the maximum threshold. I mean, no, that's why this is, well, this is as a function of the tire diameter, like you were saying.
Okay,
Coefficient
yeah.
of rolling resistance as a function of the diameter, that one, all of them go down.
Yeah.
Probably,
All of them go down. So the bigger the diameter of your tire,
but the usefulness probably falls off, because the bigger the tire, the more energy you have to actually rotate it, right?
Yeah,
So
but
everything's-
like on a bigger truck, you want a bigger tire. I mean, like obviously bigger vehicles are less efficient. They need
Yeah.
bigger motors and they waste more
I
energy.
guess-
but
So
that's
you can
interesting
just
to
get it from
me.
wheels
How do you
to
explain
Yeah.
that physics-wise? Why should the diameter change the rolling friction?
It's a ratio.
Because there's more area on the ground touching
Yeah.
it, maybe, if the or diameters now.
No, its diameter is more like
It would increase the circumference.
that one's not easy to explain.
I'm
Why?
thinking-
Why it's slightly decreasing.
I don't know why I'm thinking of bed of nails
circle.
right now.
Yeah.
A bed of nails how you spread out the weight.
Oh,
over
okay. You're thinking of the weight of the car is distributed over a bigger, circumference,
spread.
maybe.
Yeah, like the amount that's actually touching the ground is bigger, so it's spread out through.
Wow, this one.
Yeah.
There's a whole science to this, right?
Well, yeah.
Keeps going and keeps going. Oh, wow.
Like I didn't know much about this, but I've had to drive work trucks and stuff like that before, so I just know about tires.
Okay, I guess
Yeah.
the other class is getting ready to kick us out. Okay, good job, guys. We'll continue Wednesday. More good stuff.